All right. Well, hello, everybody. It's March 29th. This is SIG Automation Meeting for Nephew. Let me display the agenda. So we have a few items here on the agenda. One is just logistics. I think everybody knows this, but we started Sprint 1 yesterday. We have a project board, which is this here. And Bala might want to comment on this, but basically the idea is that each of the sub-projects and probably this, we have to figure out, because there's some things that didn't get assigned to a sub-project. So there's a bunch of things here, but maybe they're mostly SIG release. I'm not sure. So there's still a little bit to work out, and maybe Bala has some comments, but the idea is that each of these, like this is the project management sub-project sprint, and these are the pieces that are in progress, and the backlog for the sprint, and then there's an overall backlog. So Bala, do you want to? Are you here? First of all,
yes.
Do you want to comment?
Yeah, thanks, John. Yeah, I think I know that it could be confusing with the multiple views here, but I just wanted to. So the main views that we need to look at it is the individual project. One is for the SIG release, and then one for the three, one each for three individual subgroups in the automation. So we have package management. We did the planning yesterday. I mean, John, I mean, we could do the best. I mean, Wim helped us, so we did that one. And then today we had a discussion about package specialization. If you go to that board, it's a good segue. John, there may be slightly different in scope based on the meeting just happened.
Okay.
So what Wim wants to do is he wants to create a common library for all the functions that may be useful downstream. So he wants to prioritize that and prioritize implementing the functions over implementing the IPAM and IPAM controller for this one, because since those two, it has to change repos, some logistics are involved, including separating the code, etc. So the scope of this package specialization would be the items would change a little bit, which I will do after this meeting. So essentially, it will be creating the all the functions and the libraries that are the fundamental building block for those functions. So that is that we need to do that, and then I put a and then we also assigned most of it. That's all in the planning PPT, which will be transferred into this view by the end of the day today.
Okay.
That is good. And if you go to the workload one, we have
maybe Bala, just to let me on the IPAM, it's not to implement it, it's actually to move it. I think that's the thing. What we have to do is move, because I did all the changes for release 1 already in the beginning of the year. It's just the move has to happen, and I want to focus first in the first sprint on the infrastructure, because we are using the IPAM during the function, so I don't want to derail the guys. So I'll do it in the second sprint. But it's basically move. It's not basically implement. We'll change it, but just clarification.
Yeah. Thanks, Fred. I appreciate that. So this one, again, these are the things based on the execution plan that you developed, John. These are the stories from there. Again, I told Tal yesterday, and then this is one thing I also have in an agenda item today. So we need to do the planning for this board, which we have not done. That is, I also have asked Tal to do help us with that one. The other one is the SIG release one. I requested Arvind and Stephen to get. We need to do a planning on this one as well. So at this point of time, I'm confident about two subboards, which is package management and package specialization for which
Okay.
we have run some planning meetings, but the other two we still need to do.
Okay. And so, people should you should change these. I mean, my document was just a starting point. So if these are wrong, or like this is like, maybe this is 5 tasks or 10 tasks, and it's all just one here, just create new issues and schedule them and assign them. And my expectation is that each of the leads of the sub-projects will manage their board and execute against their board. And then in this meeting, we can coordinate if there are things that there's a dependency between the sub-projects or something like that. That would be how I would try to make it run if we can. Looks like we have a question from Venkat.
Hey, John. Yeah, so this is something similar to the question that I posted in the group. It is again, from my understanding, maybe this group would already know is what I assume. There are different tabs here, which is considered of different labels, and then the boards being created based on the labels, which I understand. So which also says the sprint one, the items on the sprint one is spread across on all of these tabs, or in case if I wanted to look at the sprint progress, which board do I need to look at it specifically, or is it going to be spread across all the boards?
So we could create, so I think right now this has everything, but it's not just the sprint. So you could go in.
That is correct. This is again a backlog item, right? So
I mean, you
more
can
like a
also,
backlog.
you can just for your own sake, you can just say, but we could create a board for that, right? That would be fine.
Yeah.
Like, however, if you see a need for another board, you can go ahead and create one, and you should have permission to do that.
No, before I do that, I just wanted to try and understand from this group, because I don't want to create multiple boards to confuse people. So what my intention is, like, it is okay to have a separate boards for each of the focus areas, which I totally understand the purpose of it, but maybe one single board where together, if we can just look at all the sprint ones and we know what is already done from the backlog versus sprint one, right? So that's the view which I'm trying to look at it.
Yeah. So these two you'll see are by SIG. So there's this SIG automation is split into 3 subgroups, and so this is a summary of all 3 of these, probably plus. Yeah. So, but no, that makes sense. Something like that makes sense.
Yeah.
So Venkat, I mean, do you mind if I create that so that
please.
we all can be in sync? That's a great idea, actually.
Yeah, please. Let's do that, because if I need to run around with multiple peoples to, I still don't have a complete context. But if you're ready to help me, I think definitely welcome.
I will. So basically, you want a single board.
Yes.
Okay. Basically, you want one board of all sprint items.
That's correct. All the sprint items under R1 FAO. So when I look at from the backlog, I know these are the sprint 1 items, and then these sprint 1 items are targeted. Whether it's complete or not complete, that we will take a call by end of the sprint 1. And then eventually we will move to the second board as a sprint 2. So eventually we know the progress and things like that. So that's my thought process.
Cool. Thank you so much. I think that's a great idea. I'll do that. And sorry for the confusion with multiple views.
No worries.
Yeah.
No worries. Yeah. Thank you so much.
We'll figure this out. This is what we're doing. We're figuring out how to do this. But the best way for this group.
Of course. Thank you.
We'll try this. And maybe next sprint we'll change it all. So along these lines, my plan is for my twice a week meetings for this project management. I'll meet tomorrow for the full hour, but probably starting next week, I'll drop it to half an hour if people in that meeting agree. And we'll pretty much just go through the sprint board, the board, and then set up offline discussions probably for specific questions people have or something, or coordinate on Slack, or we can extend the meeting if people want. But so that's all I have for logistics. Are there any questions on that? I did put in I sent to the emailing list, and I put on Slack for people to let Venkat know if you want to participate in a Scrum. Go ahead.
Yeah, so sorry, that's me again. I have one question related to logistics, John, before we wrap up that particular topic. So this is again for the regular, sync up between the subgroup or a group, rather to look at the sprint as a whole and then planning as a whole. Looks like one discussion has happened yesterday, which I was not part of, but otherwise I could not set up the sprint meeting as in with the region specific that we talked about last week. So I saw your thread, but I see only one response from there.
Me too, yeah.
So the question here is like, how do I go about it? Like, should I put something on the calendar and then ask people to join in or add in, or how does it work? See, my plan is to put a weekly sync. On alternate sync, we'll do a sprint plan, but on the every alternate sprint, we will look at the status of that sprint. So maybe one call per week could help us. The first call will be a sprint planning. The second week, the status of the same sprint. Again, the third week will be the sprint 2 planning. So this is what my thought process is. If you're in line with this plan, probably I can put something on the calendar, but I'm not sure from the how to facilitate that.
I can help you with that because you probably don't have the permissions, but probably
Sure.
that's a good place to start. And if people decide you want more, because there's so many people participating and there's so much going on, then you
Yes.
can add more.
Again, my point is, again, I don't want to make multiple meetings. In case if everybody is in one single meeting where we can get this information, I'm happy to join that meeting where we can get this information.
Well, so this meeting, I would expect that also will become like a little bit of that, but we'll have to see. So,
yeah,
Bala?
let's talk.
Yeah,
Maybe you and me can connect, John.
Sure.
Later.
Yeah.
So basically, I was talking in this similar vein. So now we are in this mode, execution mode. Like we see now, right? Some of the items, subgroups are planned, some of them not planned. So going further, I was thinking something what Venkat was mentioning. So when we start a new execution cycle, whatever we call it, sprint at this point of time. So probably the first day of the sprint, if we can do the planning session for everything, whether that could happen in a single meeting, that could happen on a subgroup, that's absolutely okay. In a single meeting, it may be too much, let's say. The genesis or the spirit of the question is if we can do it on the first day of the sprint, that would be really good, because then the execution, we can execute on the plan. Otherwise, we may not be able to execute on the plan.
So certainly for my sub project, that's my plan. We started the sprints on Tuesdays. I have a meeting on Tuesdays.
Yeah.
Workload cluster has a meeting on Tuesdays. I don't know if Wim's going to keep all his meetings, but he has one on Monday, right?
Yeah, Monday is good. We can do it on a Monday too. Yeah.
So
my plan
that
is to
would
do
be
it
good.
Monday.
Yeah.
Maybe Monday and Wednesday. I'm going to also trim down to 2 meetings going forward, I think, instead of 3.
Okay.
Yeah.
So yeah, I think that makes perfect sense. Like the first, the first day of the sprint or the day before the sprint starts, we plan, and then in this meeting on Wednesday. So that would all happen Monday and Tuesday. On this meeting on Wednesday, we can discuss if there's any dependencies, and make sure that, like, I can say, hey, I mean, we keep in touch pretty well anyway, but just to have broader, just in case, I guess, say, hey, I plan to deliver this, Wim, is that what you need, or is there something you need that we need to switch the plan up a little?
But would it not be useful, John, that we have, sorry, I didn't raise my hand, but that we build one meeting for SIG Automation where we discuss all together? Probably it makes sense, right? So we have one scrum that we say we have tal meeting on Tuesday and yours, maybe that should be our sprint meeting. And then we plan one more meeting, which is specific to flush out some details on the subgroups. Does that not make sense? And so that means that someone can take my slots or something. I don't mind. We might have to reorganize ourselves a little bit.
I mean, that would be fine with me. I mean, we could take, the problem is I can't do 8 a.m. easily.
No, we'll do 9, or 9 or whatever.
Yeah.
It's fine for me.
So we could use my 9 a.m. Tuesday slot every other week just to do sprint planning. That would be fine with me. And then, I don't know, this meeting might become redundant. So let's just, let's discuss that. We're almost 20 minutes in, and Aravind has a long thing to discuss. So I'm hoping, it looks like there's still some hands up too. So
my point was going to
plan. Let's figure it out as we get closer to the next sprint, which starts in 2 weeks. So Vish. Vish.
Yeah, my point was going to be similar to what Wim was saying about for the SIG automation, instead of actually having multiple, have a single one for SIG automation rather than having too many of those meetings as part of it that way. And the other thing is, in general, I think, Tom, your initial, John, your initial plan was already there where you had a bunch of work items across the different sprints for the entire release. So hopefully we can have one session.
Yeah, I don't know how
one for
realistic
automation,
that
one
is,
for
right?
release.
I just threw something, I just tried to put some shape on it, but we'll see what we deliver this sprint, and then we'll see what we need to do next sprint.
Yeah.
Okay, that's it.
Cool.
Awesome.
I think one meeting for SIG automation, one for SIG release. Yeah, we'll go. Thanks. Yeah.
Okay. All right. Let's do that then. Okay. All right. Well, thank you. I think, Wim, you had one more item on the.
Yeah, it's maybe 1 minute. So tomorrow morning at 8 a.m. for the people in the US, there is a meeting. So Orange team, so the team of Eric Dubois, I think he's on the call, is going to present what to do to deploy free 5GC. So I just wanted to announce it that some people I've talked to already. So it might be interesting. I think it's very interesting to look at this because it can help us for at least one on what they all had to do to bring this all up. So I just wanted to, so that's the only thing. So there's 8 a.m.
They even brought it up using the workshop code, right?
Yeah, so it's a bit of a mix. I don't know all the details myself. So for me, it will be also the first preview, but I would recommend people to join if you can. And definitely the people in the workload cluster, I think.
Yeah, I think I can recommend that.
Yeah,
they did a very good work on to try to analyze what was missing to set up end-to-end free 5GC, and I'm pretty sure that you will be interested by the results. But we want to discuss with you, Wim and others, to be sure that that the team detected is correct or not. That's why we need to have this meeting with you. And thank you for the invitation.
Definitely going to be useful. Thank you.
And
Eric, if possible, do you mind sharing links to anything that we should read beforehand? So we'll be.
I'm not sure we have something to share before. I'm not sure. Yeah, unfortunately,
okay.
I will ask if we can share, but I'm not sure.
Yeah, because
at least is there an agenda? I mean, is it like going through the? I know there's a lot of resources. Is it going through that or going to the design of free 5GC? What is the agenda?
No, it's much more during the workshop. So we set up some free 5GC component, but at the end of the day, for example, UPF was not, let's say, functionally ready. So the team did some modification to enable the UPF to run properly. There was some modification also on the operator, some modification on the configuration, and so on. So just to explain what has been done to be sure that we can have, let's say, a free 5GC up and running and tested using your UE Ransim tool for that.
Eric, are you the one driving that presentation, or
no?
Are you from Orange?
I will not drive it as someone from it's a Polish guy who will present it, because he did the work, so it's better than that he will present the work.
Okay. Yeah, thanks.
Can we record this presentation, because
of course
some people okay, thanks.
Okay, awesome. Thank you, everybody. With that, Aravind, you want to go through? Let me find. I have to make you co-host or something, right?
No, I should be able to present.
Oh, you can present without that? Okay. Yeah. All right. It's all you then.
Okay. Thank you, John. Hold on. Let me make sure I disable the.
So what Aravind did is he kind of went through and documented his understanding of kind of the R1 journey for the packages. So I think the idea here, sorry, I'm kind of taking over, is to give that bigger picture overview and hopefully, elicit questions and understanding.
Yeah, thank you, John. Yeah, as John mentioned, one of the things like I was personally struggling with was there were a lot of meetings, and many of the meetings I personally was not able to attend. Right, I was imagining other people will also be in similar situation where um, the, the the teams, individual teams in different sub projects will probably be experts in their area, but we wanted to have something which is a little bit overarching and at least shows the high level flow so that we can all follow along. So that was the goal. And the two objectives, right? Like high level capture the expected sequence of events, and then also kind of figure out what is the contract, right? What is each project kind of handing off to the other sub project? So that's the idea. So this document is more or less based out of, I mean, the CRDs that it uses are based on the VIM's CRD document, right? So I know that some of the details in the document are evolving also, right? As we are defining the API repo, some of these might change. So this document might not be, might have to change as well, right? If it wants to reflect the current state. So that's a caveat. So sub-project ownership is that, so the three sub-projects, package management, specialization, and workload cluster. And we have kind of tried to call out which sub-project is responsible for which set of sequence, right? Like steps 1 to 4, package management, 5 to 10 is kind of package specialization, and workload cluster is steps 11 to n, right? So those are the sub-project ownerships. And one prerequisite that we have called out here is that before this flow that we are going to look at starts, there needs to be a bunch of preparation, right? Like workload cluster creation, provisioning is not part of R1, right? It's done manually. Same with management cluster, right? So that needs to be prepped. And what are the different steps that needs to be done before this flow can start is kind of called out here. It's not comprehensive. We still need to work on. So this is a working document. So by no means it's perfect. So we have to kind of work together as a team to kind of evolve this more. So is this legible enough? I just want to make sure before I go too deep.
It's pretty tiny.
Yeah, I mean, we can see the text, but the diagrams are.
How about now? Is this better?
Can you do one level up? Let's see.
I'm at 150 right now.
Oh yeah. Okay.
Oh, it's clear only now. 200 is what makes it, is it?
No, I don't know. Maybe my eyesight is not good. Let me put it that way.
It's even here, like UPF blueprint package, SMF blueprint package are fuzzy.
Oh, okay. So let's just use this. Is this clearer? This is the original source. Is this clearer? This is the source. So I'm hoping. Oh, hold on. This should be clearer. I'm hoping.
Yeah, it's pretty good. That's better anyway. It's good. It's good for me. It's good enough, but.
Okay. So let's go with it. Yeah, let's get started, right? So before I go into the flow, so this diagram doesn't have all the arrows, perfect, and the sequence. This is not going to give you all that, right? But at least it gives you what are the different blocks that put for Nefio R1, right? That's the main takeaway from this, right? So first let's start with the legends, right? All the blue boxes are Nefio controllers, Nefio operators, right? I will use controllers and operators interchangeably. So anyway, so all the blue boxes are Nefio controllers. The orange box over at the top in the Nefio management cluster is ports and ports related controllers and other components, right? And the dark green one here is config sync. And the what I've shown as external on the far right is infra-specific backends, right? Which kind of, like in the IPAM case, it's the one that gives us the IP allocations, right? But you can imagine it could be other infra providers. But in our example for R1, we are showing an IPAM backend that we built, right? So those are the components. And obviously each workload cluster syncs to its own repo. So there are two repos, workload cluster 1 repo and workload cluster 2 repo. As we have seen from our previous discussions, is once the package is published in the repo, it gets synced by config sync. So that's what this is trying to show. And of course, as always, there is a blueprint repo, which is our template. All the templates for the different NFs are held there. And so that's the dry package, if you will, right? And then as part of our hydration flow, it will get hydrated. And once the package is wet, it will get published to these workload repos, and config sync will take over from then and kind of apply the KRMs on the workload clusters. So that's the very, very high level view. And please feel free to stop me if there are questions. But that's the but we are going to dive into this in greater detail. But this is just like a 10,000 feet view for starters.
I think probably it may also make sense to identify, because specialization is all driven using the kept functions. Probably there's that intelligence aspect as well. So probably show that in some other legend or something.
Yes, no, I agree. We should add that. Yeah, I didn't add. I was just highlighting controllers, but yeah, kept functions also we should probably represent it in some way here. But we are talking about it in the doc. It's just not represented here. But a good point, Ravi. Yeah, thank you. We should do that. Okay, cool. So let's proceed. Go to 125. So here is a brief component description. It's very brief, but I think it should provide an overall view, right? The topology controller is a controller, which could be optional, right? We'll look at why that is. That creates package variant set resources based on the topology that we give it as input and some customizations. We'll look at all of this in detail. So one thing I'm going to assume is folks here are familiar with what a package variant is, what a package variant set is. So we will assume that in this discussion, right? We won't like go too deep into the basics of that, right? So that's an assumption that I will make because we have had at length discussions about this through other workshops, right? So the edge status aggregator that we saw earlier is a controller. I'll just show here, is a controller that will kind of subscribe to status events from watcher agents sitting in the workload clusters and kind of aggregate the status information in the management cluster. So that's the edge status aggregator controller. The next is IPAM allocator. This we know that it's a controller that allocates IP, and the way it does it is by interacting with the IPAM backend. And once it receives the IP, it kind of injects those IPs into the package revision resource, right? VLAN allocator is similar, except it does the same thing for VLAN. Watcher agent is an operator that watches for a set of GVKs that it received from edge status aggregator controller, and then it sends the status back to the edge status aggregator. NF operator that lives in the workload cluster is the one that reconciles these kinds of CRs, right? It could be UPF deployment, SMF deployment, or AMF deployment, right? And based on these CRs, it creates the KRM resources and eventually enables the NF functionality. Yeah, that's a super quick, brief description of all the components. But we are going to see a lot of them in action as we go through the flow in greater detail. But I'll pause there for a second. Any questions, comments before we move ahead? Okay, cool. So in this specific flow of events, right, the main thing we are going to focus on is our favorite UPF as always. Here we are just showing how a UPF package is hydrated and deployed to the workload cluster. We have not yet shown the details of edge status aggregator and watcher agent, as some of them are still being fleshed out. And so this is just a simple flow showing how a UPF package is hydrated, right? And as I've called out here, the topology controller, the one that is shown here, could be optional, and one can choose to directly create package variants set if they so choose to, right? But let's look at how topology controller could be helpful, right?
Yeah, if I could just comment there.
Yeah, go ahead, John,
so what we've discussed in some of our calls is using a package that contains package variant sets. So I think there's even an issue for creating one to do that with the 3. So that's one way to do it. And of course, what Arvind's talking about here is having a controller in place of that package effectively, that rather than having it be a static package that we clone and manipulate, we have a controller that can do that automatically. So this is in the issues as well as something we might build. And since we have it from the seed code, we may well take that, but we're trying to build up layer by layer. So we're not jumping right into that in sprint 1.
Right, exactly. So right now the plan of action for package management is to create like a kept package which contains a PVS, right? That's the plan of action for now. Right, John?
There's multiple PVSs. So you'd have one for the UPF, you'd have one for the SMF.
Right, right, yeah. One per NF. Yeah.
Different sets of clusters. Yeah.
Understood. Okay. Hey, Bala,
Bala?
please go ahead.
Yeah. So yeah, thanks, Arvind, for doing this. This is absolutely great. So one question, specific question here is, we are talking about user expressing the intent of their network service deployment by expressing the topology in the way that a network planner understands. So if we go that path, don't we have to build the topology controller?
Right.
Yes.
That's what this is just a sample topology controller. It's not going to be like if you're going for traditional orchestrators, right? Like that's there out there. They have a choice, right? They could create packages directly and use PVS, or if they so choose to, they could express, they could interact with it using this NF topology CR.
So the short answer, Bala, is yes. If we want to interpret this NF topology CR, we need a controller to do it. Aravind is presenting that as part of the overall, as the way to kick off the flow. In our first sprint and maybe our second sprint, that's not how we're going to kick off the flow. We're going to kick off the flow by just instantiating a package that contains what would effectively be the output of one of these controllers. Wim has talked about the idea of having a tool that can create those packages, which might process a CR like this. That's effectively the same as a controller, but done sort of non-declaratively, done imperatively, like as a tool. So there's different ways, and I think that it can be useful to see different ways. I was afraid this might cause some confusion, this first step. Like, don't jump too heavily on this. We're not going to do this right away. But the idea would be like, we have different paths to initiate the intent or capture the started intent. And this is very similar to the 5G core topology controller we started with. And the idea is that ultimately, like R2, 3, 4, somewhere in there, you can actually have a controller that's not sort of just statically having a set of things here, but actually is able to reason about that topology and make decisions about that topology, either based on feedback or based upon some other lower level, like other inputs or higher level intent inputs. This is almost just a very simple example without any of that higher level intent intelligence, but you have to sort of build up that model. So it's like, you know, we start with a basic PVS, then we put a PVS in a package, then we put multiple PVSs in a package. Then we create a resource that can reason about the relationship between those PVSs and create them directly rather than them being in a static package. That's what this is. Then we create something that takes that another level further and takes some resources and input, like a geographical distribution of population or something, right? And then can reason along with the physical sites, you know, and can reason about a topology on top of that. The idea is we build up from lower levels to higher levels over time. And so Arvind's kind of showing an example because it's already in the seed code. So we figure we should show how it would be used. An example of a starting point on that journey, climbing up that stack. Does that make sense?
Yeah. Yeah. Thank you so much. Yeah. Thanks, John and Arvind. Yeah.
Yeah. So yeah, so this topology CR is submitted along with a bunch of customizations, right, to the Nephew management cluster. So so we shouldn't worry too much about the actual names here because they're a little bit misleading. And I just use this as an example because this is what the seed code came with. But of course, if we are using enough topology, we could change the names and we have the flexibility to do that, right, in the scope of R1. But for now, let's go with this. So here, what we are saying is, hey, I need a UPF NF on workload cluster 1. I need another also UPF on workload cluster 2, and I need SMF on workload cluster 3. So this is just an example to illustrate the capability, right? And this connectivity is the CR as it stands today. It just is helping build a graph. So here, all it's saying is this UPF is connected to this SMF by mentioning this ID. And here we are saying that this UPF is also connected to the same SMF. And on the SMF side, it shows that it is connected to both UPFs, right? By giving these IDs. This will help us build a graph if we so choose to, right? On what the topology is. That was the original idea from the seed code. So one thing now, if we want to have a topology controller that can build package variant sets, one per NF, right? First thing is we need to teach the topology controller, or we need to give it inputs that it needs to create these package variant sets, right? So here's one way to do this, right? And this is new, right? And it was not part of seed code or anything, and we need to kind of finalize this. But here's one way to do this. We could list a set of GVKs that needs to be used for creating the injection selectors that we are going to look at in the next step for creating package variant sets. So basically what we are saying is this is a customization that we want to do before as part of hydration is what we are saying here really. So here we are saying inject the 3GPP config. We'll look at what that is. This is just illustration example. Another one is free 5GC UPF config. This could be things like, hey, I want to enable feature A, feature B, or disable feature A, feature B, and so on, right? So here I'm showing the GVK. So the way we want to work on step one is first apply these GVKs, for example, right? You apply these 3GPP config and free 5GC UPF config, assuming these resources are available in the NFO management cluster. Then you apply the NF topology with these customizations, right? So now that all these things are available, topology controller can now successfully create the package variant set, which is what step 2 is, right? And probably this was discussed at length in package specialization group, right? But I'll briefly introduce this. So the package variant set is the resource that we will create, which will be used to create package variants from it, which is what we call fan out, right? So here what we are saying is the topology controller is creating this. So the one thing that we have not mentioned here is that the topology controller also needs to know what is the upstream blueprint repo. Here I've just taken the liberty to kind of assume that topology controller knows it, but you can imagine that we could add that upstream blueprint repository either through NF topology or through a different CR. But that's just a minor detail. But here, assuming topology controller knows the upstream repo, then it has to do two things, right? It has to create an upstream package. So for that, it needs three things. The telco blueprints is the repo. And next, it needs to know the name of the package on that. And here, the way we have constructed this package name is a combination of these three things. So you see free 5GC, large UPF, a combination of these three is what this name comes from. And version 1.0 comes from here, right? So I think the bottom line is in the NF topology, the topology controller needs to receive few things. Hey, what is the UPF package I need to use? What is the workload cluster that package needs to land at, right? And what is the repository, blueprint repository from where I need to get that? If these three pieces of information is available in NF topology in some way, shape, or form, then it's in a position to create this part of it, right? And after that, as part of package variant set, it needs to mention a bunch of targets, right? So this is basically what is the downstream targets that we are kind of trying to hydrate this to, right? So here you see that package variant set today offers this option of being able to specify individual packages. So what we have said here is there are two packages. Package 1 is for workload cluster 1, and the name of the package is free 5GC. And package 2 repo is workload cluster 2, and the name of the package is free 5GC large UPF. How did topology controller know how to create this? Is because at the top, it was explicitly stated what the cluster names are, right? Like workload cluster 1, 2, these are the two clusters where you want UPF, right? So based on that information, this was created, right? So now that we have created the upstream and the targets, the next thing is to create the injection selectors. Basically, what we want is for the package variant set and the package variant controller to do two things, right? Like one is do cluster invariant injections, which is to say that these are static pieces of information which needs to be part of every NF package. So that's cluster invariant. And we also need some cluster variant information, which is different for each cluster, right? So both of these can be accomplished using the package variant set controller. And the way to do that is, so there's this concept of injection selectors. And I must highlight, this is not a feature that's available with package variant set today. Like if you go to the repo, you probably won't see it. And this is something that will get added to Porch, I'm assuming by No, likely by R1 timeline, right? So we are going with that assumption.
Hopefully by the end of sprint 2.
In sprint 2? Okay.
So I have to finish, hopefully by the end of sprint 1, I'll get some of it in there, but yeah, we need it ASAP.
Okay, great. So all we are saying here is this, right? Hey, this is the first two are static pieces of information. That is to say that it's the same for all the clusters, all the workload clusters. And we are saying inject this GVK or at least create package variants injection selector with these GVKs, because as far as package variant set is concerned, it doesn't know anything about the package. It is the one that's going to create package variants. So for package variant set is concerned, it's going to create this GVK and add it to package variants injection selector, right? That's what we are telling here. Similarly for free 5GC. So these two are simpler, they are static, but the next one is a little bit more nuanced, right? This is cluster variant stuff, which is we want separate things for each workload cluster, right? And this is a little bit nuanced. So let me try to clarify, and maybe John, please chime in as well. So here, basically what we are telling the package variant set is you need to inject a kind called cluster context, right? But the name for that cluster context should come from this field for these targets. Let me try to explain. I'm sure that was not clear. So if I go to the repositories, right? So let me back up a little bit, give some context, and then we'll jump to it. I think it's important. So let's go here. So like I said before this workflow starts, we had already prepped the management cluster, correct? And as part of prepping the management cluster, we had registered a bunch of repositories to Porch. The blueprint repository, the workload cluster repository, all of these were registered with Porch. When we register it with Porch, right, these are the CRs that are kind of created, right? Like one repository CR per workload cluster. As you can see, workload cluster 1, workload cluster 2, and there is, of course, a telco blueprints repository CR. So these exist. And if you see, there is a label here which says cluster name, and it says workload cluster 1, right? And also, if you see, there is a label here for workload cluster 2 that says workload cluster 2 cluster name, right? So now if we go back with that information in mind, right? Now what we are saying here is, hey, package variant set controller, create an injection for each of the package variants that you create for this kind, but the name needs to come from the cluster name that we just saw. So with this, what package variant set controller does is, as you can see here, it has added a GVK for the package variant it created, but here it's saying workload cluster 1. So this package variant is the package variant for that is meant for workload cluster 1, as you can see from the downstream, right? Let me make it a little bit bigger.
Yeah. So exactly. So the idea is, right, package variant set doesn't know anything about injection per se. What it knows how to do is create package variants. Package variants allow you to say, inject this, match injection. Just as a recollection, the way injection works is the package internally has to have a resource with a specific GVK that's annotated to say, I'm an injection point. So this is the package saying, I'm able to be configured by messing with this resource that's in the package. The package variant controller has a list of injection selectors. And so when it's creating the clone, it goes through the package, looks for anything tagged as an injection point, and tries to match that to one of the selectors it has. And then it tries to use that selector to find a resource in the cluster. And if it does, it copies the spec of that resource from the in-cluster resource to the in-package resource. So that's the injection piece. So the package variant set, recall, it's saying, I'm going to create a bunch of package variants, and it's got a list of targets that it uses, and it generates one package variant per target. So you can either tell package variant set, for every single one of those, create a injection selector that's static. That's the package invariant stuff. It's saying every single one's going to get this fixed name, going to inject this fixed name, carrier A config. Any package you're creating, that obviously advertises that it can accept that injection. But it can also say, hey, I want to derive the name of the injected resource from the target. And in this case, I'm using a field in the target metadata.labels and the specific label cluster name, I'm using that target value as the name. So the PVS does that resolution. The package variant set, as it's creating the package variant, resolves that the package variant itself knows nothing about targets, right? It's only the package variant set that knows about targets. So it has to resolve that indirection by figuring out what name that applies to. And in the package variant itself, it then creates selectors with 3 static names. It's just the static name in the package variant is different. The last one is different for every package variant. Liam.
Yeah, does it make sense, or could you have more than one injector selector you're selected by name like that, so if for different things, or am I misunderstanding you?
So this
So
is
this is a good question. So whenever you're talking about matching, so first of all, there's the package advertises, and right now, as the design is written, the code's not written, as the design is written, and it's not even, that's not fully written, is it's in comments. What package variant will support, what I plan to build, is that the injection is done based on GVK and name. So you take the GVK, the group version kind, from the in-package resource, and the package variant controller will look in cluster for the same group version kind with the name listed in the package variant resource. So that's how the match is done as it's written. Now, in theory, you could do that match with something other than name, labels. I don't have a use case for a multi-match there, and I don't know what to do with a multi-match there. So
but this isn't the level at which you'd trigger the injection function, say in the package specialization. That's the package. This in fact is probably triggering the package specialization, is it?
So I think
that's actually separate. So this is like the first layer of customization.
So sorry, John, can I intercede? I think we are jumping ahead to package variant and specialization. So can I walk through the flow? I just want to make sure this part is first conveyed clearly, and then we'll go into package variant, right? Like, because I feel like we're going into package variant, which is the next step. Is it okay? I mean, maybe after step 3 or 4, we'll pause and take questions, and then is that okay? I think we are jumping ahead to step 3. I really think that. So
that's fine.
Sorry, Wim has his hand up. Wim, please go ahead.
Ravi has his hand up first, I think.
Oh, sorry, I didn't see.
Ravi first. Okay. So there was another relationship that you wanted to kind of address, right? I mean, you said your 2 UPFs have to be controlled by the same SMF. So in that sense, like somewhere when you have to also emphasize that when you configure the UPF deployment, you are probably giving the same kind of pointing to the same SMF, right? So is that taken care in that injector as well before you hand it off to when you create these packages?
No, that's a good question. No, it's not. Like, I think what we were, so again, we were using the seed code CRD as is, right? I think the intention there was at the topology controller level, we wanted to have a graph of what the topology is, right? So here, if you can give these inputs, then you can potentially create a graph of which SMF is pointing to which UPF, and then you could potentially accumulate status and kind of track it, right? That was the original intent.
But Arvind, I'll say that Ravi's point is really good, because it actually makes a point of like why you might want to use a topology controller. So you're right, Ravi, you could actually have the topology controller configure some injection point based on those connectivities. It doesn't do that today, and it doesn't do that in this description, but I think that's a really good point, that as opposed to what I was talking about where we just put it in a static package, that this could be a reason to do it this way rather than the other way. Now, there's other ways to do it. You could do it by label. So I think that's not in this flow that Arvind's describing, but I think it would need to be in real life. So it's a good point, and we should probably scribble it down somewhere, but most likely it's gonna slap us in the face when we get to actually deploying things anyway. But that's a great point.
Yeah, because the service topology intent has to be carried through the pipeline at some point.
Yeah, it's missing in this description, but yes, good point.
Yeah, yeah. Maybe quick also on the injectors is, are they being watched, the resources that are injected? For example,
Yes.
if the cluster context get changed, will it create a new revision?
Yes. The package deployment controller, that is the thing we did in the POC, does that today. We haven't implemented it in package variant yet because we haven't implemented injection. But yes, we said it's watched.
Yeah, because in the specialization we are designing for change at the moment, so that's why I'm bringing it up. We haven't discussed it so far, but it means that we have to take care. Worst case, the content of cluster context changes, and there is some new data in it. I mean, this is probably hypothetical, but we have to design for that, is what I'm trying to say. So, okay, so it will watch the thing. Okay, cool, thanks.
You'll get a new draft, and then yes, so.
Okay.
Okay, cool. So we were at this point, right? The cluster name. I'll just paraphrase or summarize, right? So how this cluster context is used to create package variants is because package variant set knows what the targets are. So it knows the targets are workload cluster 1 and workload cluster 2. Using this, what it does is it goes to the repository CR, because for each workload cluster, there is a repository CR living in the management cluster, right? So it goes to the repository CR and looks for this label, which is metadata.labels.cluster name. And whatever name it finds there, it uses it to create package variants 1 per cluster. So if you can see here, it creates API version kind. So these two is the same as whatever was in the package variant set. The only thing that changed was this name. And this name was got from the repository CR that we looked at earlier.
Yeah, actually, unfortunately, now going through this, and it doesn't work with package repo pairs. There's no target. It doesn't know what the because you've explicitly put the repo as opposed to having a target
the repository
object.
name is this, right? The repository name is this, workload cluster 1. So
yeah, okay, we could probably implement it that way. It's not implemented yet. It's just not the way I was imagining implementing it. But anyway, continue.
Yeah, okay. So anyway, so based on that, right? So if you can see that 2 package variants are created, like one for workload cluster 1, you can look at it from downstream, right? And one for workload cluster 2. And each of them have the static injections, which is common. You'll see the same thing for package variant set for the workload cluster 1 and 2. And the only difference is this cluster variant stuff, which is cluster context. And a different one is created for each workload cluster, as you can see here, right? So far we have gotten to partial fan out, if you will, where we have created 2 package variants, 1 per workload cluster. And now the real stuff needs to happen, which is modifying the package and stuff, which is what will happen in the package variant controller. So at step 4, the package variant controller reconciles the 2 package variants that was created, and basically clones the upstream packages and creates PRR, which is package revision resources. So let's look at that, right? So the 2 package revisions are created. I've taken the liberty to name it this way. I don't think it's named this way, but this is for ease of reference. I put the same name as package variant. I think package revision, if I'm not mistaken, has only owner reference. But anyway,
do you mind increasing the font if you don't mind?
Oh, I'm sorry. Yeah, is this better?
Yeah, it's better. Yeah.
Okay, perfect. So so for each package variant, there is a corresponding package revision that's created in draft state, right? As you can see here, this is for workload cluster 1, and this is for workload cluster 2. So in the rest of this flow, we have just focused on one workload cluster, because that itself, there's a lot of verbiage and we were trying to cut down on that. So we are focusing only on the workload cluster 1 and see how that's iterated, right? But that should give a good sense of how things work. So here is a package revision resource that gets created by package variant when it clones the upstream. So basically whatever was in the blueprint package, all of the contents of that comes under resources field in the spec of package revision resources. So you can see that there is a capacity, there is a networking requirement. We should talk about what these are. 3GPP config, UPF deployment, cluster context. Cluster context got injected by the pack. So this cluster context is special. Let me back up a little bit. I'll make the font bigger. think we should talk about what was in the blueprint before going into how the PRR was created, right? I think that's important. Okay. So this was in the blueprint. That was in the telco blueprint repo. This is the package that is getting cloned by the package variant controller, right? So let's start with the kep file. The kep file will look something like this. It's not perfect, but it should give us the idea of how things will work, right? So this kep file contains multiple kep functions, mutators. These we will see in the next steps, which is part of the package specialization group, right? So there are 4 kep functions that are kind of called out here. I don't know, Wim, if the naming is different, we can change it. I think I did discuss with Wim, but yeah, I don't know if the naming has changed, right? But there are 4 kep functions called out here. We look at what those are in the next steps.
And there is one more in the meantime. So we split it interface and DNN into. So there is a 5th one right now.
Oh, I see. Okay.
But time check here, guys. We have less than 2 minutes left.
But it's not important, I think, right now.
Yeah, okay, sounds good. Yeah, so I don't think we'll be able to finish this presentation obviously today, but at least we can go for 2 more minutes, I suppose. So these are the 4, or like as Wim mentioned, there could be a 5th one. But the point is there are a list of kep functions which are part of the kep pipeline, which will kick in as part of the specialization starting from step 5, right? Or even in step 4. And there is a capacity. The capacity here is mostly like a metadata, if you will, because the idea was, hey, this is a NF blueprint package, which is coming probably from the NF vendors, and this is what they qualified it for. At least was the thought process. And then to realize that requirement, to realize that capacity, there are a bunch of networking requirements from the NF vendors, right? So they could say, hey, I need SRIOV. So as you can see, the API version here, we have tried to call it out as rec, standing for requirement, right? So there is a bunch of CRs that we are defining, right, as part of R1, and those are interface requirements. There is a requirement for N3. We are saying we need SRIOV with VLAN. There is a requirement for N6 and N4. Right, and also there is a requirement for DNN, which is the user IP pool, if you will, right? And that's for internet. So those are the network requirements. And this is a 3GPP config, which is a dummy right now. And we'll see why this is important, right? And there is a UPF config, which is a dummy config. These will be changed as part of the injection steps, which we looked at earlier. And there is a dummy UPF deployment. So these will get hydrated. So the eventual goal is to create this hydrated UPF deployment, which will then get pushed to the workload cluster. But yeah, I don't want to rush. So I think we should probably stop there. So I think we have gotten up to step 3, I think. And we need to look at step 4 in greater detail. Step 4, we'll start from step 4 probably in the next meeting, whenever that is, when we get a chance to discuss this. Yeah, I'll stop there. John, after you.
Okay, thank you. So yeah, please folks follow up on Slack. I'm sure Arvind will be happy to answer questions there as well. Much of this we've talked about in various other meetings, but he's put together it all in one flow. So hopefully it will be helpful to folks. And other than that, I think we're all done. So thank you all, and we'll talk soon. Bye-bye.
So much.
Thank you
so much. Thanks.